all things trigonometry and Pythagorean theorems. So this will involve every single thing that basically has a right triangle in it. So whenever you see right triangles in pictures, if you see this 90-degree angle, you should think in your head, trig, you should write SOHCAHTOA. And you should write the Pythagorean theorem, a squared plus b squared equals c squared. So even if you don't know what to do, if you see right triangles with the square or 90 degrees, think of these two things as it's probably going to help you solve the problem. So write those at the top of your page all the time. When you get your scrap paper at OST, just write it at the top right away. And every time you see a right triangle, see if you can use it. Okay, so the first one says, what is the area of this symmetric logo the trucking company wants to paint on the parking lot? So symmetric just means it's like a mirror image of itself. So we can assume this whole bottom part is exactly the same as this whole top part. This right and left are obviously the same as each other. So you could probably just guess that by looking at this picture. If you don't have these measures up here, you're going to assume it's going to be the same. So they need the area of it. So these are clearly triangles. So you would look up on your formula sheet to double check, and the area of a triangle equals 1/2 times base times height. So obviously this is two triangles exactly the same. So if we find the area of this bottom triangle, we can assume the top triangle is going to be exactly the same. So the items we need are the base. So it looks like we have the base. The base is 16 feet, but the height is going straight up from the middle. We do not have the height. So the height of this, I'll do it in this color, is this piece right here, which we do not have. But we do have some right triangles. So on this right side over here, let's just go ahead and look at this right triangle on this side here. So I'm going to just redraw it here so we can see it. So that little right triangle, it has a 17 on the side here. Now the 16 is not the whole bottom, so this is clearly cut in half. They said it's symmetric, so this is going to be 8, which is half of 16 right here. So for this, we can do, figure out this height that we're missing, I'll call him h, by doing the Pythagorean theorem. So, because we have two sides, we need a third. So remember, Pythagorean theorem is a squared plus b squared equals c squared. Now remember, you have to remember that the c has to be the hypotenuse of the triangle. And the hypotenuse is the longest side, the side opposite the right angle. So if this is my right angle, my hypotenuse is over here. So this is going to be my c. And my a and my b don't matter. I could switch these up as long as my c is good. So I'm going to go ahead and plug this in, 8 squared plus, I don't have this, I'm just going to call him h squared equals c squared, and that's 17 squared. So grab your calculator, let's do 8 squared, 64 plus h squared we're missing, 17 squared, put that in your calculator. You should not be staring at me. You should be punching in your calculator just like I am and get 289. Remember, do your algebra. Subtract 64 from both sides. Get your calculator. H squared is equal to, do your 289 minus your 64. And you get 225. And remember, to get rid of the squared, to unsquare it, you must square root it. On your calculator, remember you're going to hit the second button. Do it right now with me. Second button, and then the x squared. So if you do second x squared, you get on your calculator screen, it'll look like this. And then you could put the 225 right in there. 225 equals, and you'll get h equals 15. So that means the height of my triangle is 15. So this is 15. So my height is 15. So the area of a triangle, this bottom triangle only is 1/2 times 16 times 15. 1/2 times 16 times 15. Remember, if you're going to use the 1/2, you do 1, and then use your ABC button, and then 2. So I get 120 is my area. But remember, that was just the area of this triangle. Now, since I have 2 that match, I have to double this. So times this by 2 to get the whole figure. And I get 240. And this is feet. And it is squared since it's area. Number 2, we have triangle BDE. So I'm going to color this one. B to D to E is similar to triangle BAC. B to A to C. Okay, I'm going to draw these separate from each other in 2 different colors. So remember, have your colored pencils at your OST. Draw separately. So this is triangle. Can't even read my stuff. See, this is why I draw them separate. Triangle B, D, E, and it looks like that 10 is on the bottom, is similar to, what does similar mean? Similar means that it has, let's see, this is A down here, and B up here, and C over here. Now remember, similar means that the angles are the same, and the sides are proportional. So similar. Congruent, angles, sides are proportional. And that means we can make some proportions. Remember, fractions that matchy-match. Proportional. I should call it, what's this, proportional. Okay, so I don't look at, it doesn't look like I have any numbers on the orange triangle, the big one. Okay, so they're similar. Remember how we match them up, stack them up? B, D, E on top of B, A, C. So that way you make sure all your pieces matches. B matches, D matches A, and F matches, or E matches C. So we're all good. Okay, but they do tell us AB equals 9. So AB is on the orange guy. So AB is 9. Okay, so this is all we have so far. It says the cosine of angle BAC, BAC. So cosine of BAC is 0.6. So the cosine of this guy, 0.6. What is the length of AC? So we are trying to find this length right here. So let's call him X. Okay, so we have to stop and think. What do we know about cosine? Well, if you saw this right triangle, you would have obviously written this at the top of your page. So cosine is adjacent over hypotenuse. Adjacent over hypotenuse. So let's write that down. Cosine equals adjacent over hypotenuse. So we know that 0.6 is the adjacent over the hypotenuse. So all we got to do is let's see what we have here. Now, here's the thing we know. We know that these 2 triangles are similar. So like we said, the angles are congruent. So if the cosine of this angle is 0.6, that means the cosine of this angle is also 0.6. They're both exactly the same, right? These are 90, and then you'd be able to figure out the other one if you've got some numbers. But we need adjacent over hypotenuse. So the adjacent over hypotenuse of BAC, adjacent over hypotenuse. So adjacent is going to be, let's go ahead and label all these. So if I'm talking about this angle, this is my hypotenuse, right? This is my opposite. And this is my adjacent, correct? Same thing if I label this one. This across from the right angle is my hypotenuse. Across from the angle I'm talking about is opposite. And this is adjacent. Okay, so we have what? Adjacent over hypotenuse. adjacent over hypotenuse. So we have 0.6. If I just look at this triangle, 0.6. Now let's do, which one are we trying to figure out? This one. So adjacent is 9. Hypotenuse is x. Adjacent is 9, hypotenuse is x. So we know that 9 over x is equal to 0.6. So we do have a proportion we could solve here. Remember, let's put this guy over 1. Let's crisscross multiply. So that means we're going to get x times 0.6 is 0.6x is equal to 9 times 1, which is 9. Okay, so I'm going to now try to get x on the side by itself. So to get x all by itself, I got to divide out 0.6, divide out 0.6. So I've got 9 divided by 0.6 equals 15. So I have x is equal to 15. So I'm going to put that in my picture. X down here is equal to 15, and that was my AC. And I think that's all they're asking for. What is the length of AC? So the length of AC equals 15 units long. We could have figured out some other stuff on this one too. We could have used the adjacent and hypotenuse here. So we could have done 0.6 equals, if I wanted to find this piece, like call him y over 10. So we could have also done it on this side, but we actually didn't even need this guy. We just needed to know that they were similar, that's all. Number 3, a ladder leans up against the wall as shown in the diagram. Remember, whenever you're drawing a picture, if they don't give it to you, make sure you have the ground and the wall and a ladder that's leaning. So the length of the ladder, this is the ladder right here, it's leaning, is 4 meters long. How far is the top of the ladder from the ground? So where is my ladder? This green line is my ladder. So the top of the ladder is right here. How far is it from the ground? So that's down here. So we are talking about this piece right here, right? So this is my, let's call him X. And let's note, round to the nearest meter. Nearest meter means whole number. So the whole number, so no decimals. So you're gonna have to look at the tenths place to see if you have to shove it or not. Okay, so once again, this makes a right angle. So you should have seen the right angle and you should have written on your paper these two ideas, because one of these is going to save you. If you have two sides and you want the third side, you're going to use this. If you've got some angles in a side, you're probably going to use trig. Now for this one, I've got an angle and a side, so I'm going to use trig. So I'm going to use SOHCAHTOA. Oopsie, SOHCAHTOA. SOHCAHTOA. Okay, so let's take a look. All the time you go to the angle you have. Remember, never circle the right angle. So I'm going to circle this one. I'm going to label on my sides. So across from the side I circled, or the angle I circled, is my opposite. Remember, I'm always labeling sides now, not angles. Across from the right angle is the hype. And my bottom piece is my adjacent. So since I'm looking for the orange piece, I'm definitely going to use my op, right? So my op is my missing. I do have the angle measure, so my theta is 68 degrees. And the other piece they give us is the height, which is 4. So looking at this, I've got op and height. So if I look at my choices here, op and height are right there. So I'm going to be using sine. So winner, winner, chicken dinner. So remember, you always write the word first, sine. You'll put the angle next. So this is the word, and then the angle, and then the equals, and then the fraction. Got it? So I've got the word first, sine, then I write the angle, which is 68, then I write my equal sign, and then I make my fraction, which is opposite over hypotenuse for this problem. So my opposite is my question mark, so I'll call him x, and my hypotenuse is 4. So this is what I've got. I've got sine of 68. Remember, I'm looking for a side, so I just literally hit sine 68 equals, no second button, and I'm going to go out 4 digits to be safe. 0.9271 is equal to x over 4. Put that in your calculator, see if you get the same thing. Make sure your calculator's on degrees. If there's any other weird words showing at the bottom of your screen, hit second 0. And they'll ask you if you want to reset, and say yes. And then enter, and it'll be all set perfectly. Okay, so let's go ahead and solve this. Put this guy over 1, crisscross multiply. So 1 times x is 1x, which is just x, right? So you don't have to write this little 1 here. He's just x. And then we do 4 times that. So 0.9271 times 4. Put it in your calculator, and I've got 3.7084. Okay, now it says to the nearest whole number, which means I can't have anything after this decimal, but I got to look at this guy and ask myself, do I have to shove? I have a 7 here, so I am going to shove the 3 up to a 4, and my answer is going to be 4 meters. Part B, how far is the bottom of the ladder from the wall? So it's the same picture. How far is the bottom of the ladder from the wall? So the bottom of the ladder is here, and the wall is here. So I'm looking for this purple piece. So now I'm looking for the purple piece. I'm going to call him Y. So I've got this. Once again, I still have the angle theta is 68 degrees. I still have my height, which is 4. And now I'm looking for my adjacent, and that's going to be my y that I don't know. So now I'm dealing with A and H. So I look at my code here, look at A and H right here. So I'm going to be using cosine. So remember, the same exact thing. Put your word first, cosine. Put your angle second. Word, angle equals fraction. Word, angle equals fraction up here, A over H. So A over H, I'm going to need Y over H is 4. So now I've got cosine 68. So remember, put that right in your calculator. Cosine 68. I've got 0.3746 is equal to y over 4. I'm going to put this baby over 1. I'm going to cross multiply. 1 times y is just y. 4 times that. 4 times 0.3746 is 1.4984. Okay, let's check and see what we have to do over here. It says, how far is the bottom of the ladder from the wall round to the nearest 10th of a meter? Okay, so what number's in the 10th place? This 4 right here is in the 10th place, but you know I got to look at this 9 to see if I have to shove the 4. And 9 or 5 or above, give it a shove. So this 9 makes me shove this 4 up to a 5. So my answer is going to be 1.5. Number 4, triangle is shown. What is the length in centimeters of side CD? So I'm looking for side CD, rounded to the nearest 100th. Okay, so I'm looking for this side. I'm going to call him X. So once again, go to your picture, circle the angle that you want or have, but not the right angle. So I can never pick this right angle, right? So I'm going to circle this one. I'm going to label all my sides from there. Go opposite him. He's my op. I go across from the right angle, and he's my hype. And that makes this X be my adjacent. So what do I have here? I've got my theta is 44. I've got my op, and he's 16. and it's my adjacent that I want, and he's my x, right? So it looks like I'm dealing with O and A. Obviously, what's O and A? Look at your little cheat sheet. That is TOA. So, exactly the same. Put your word first. Tan. Put your angle second. 44. Put your equals. Put your fraction. Opposite over adjacent. Who's opposite? 16. Adjacent, x. Okay. Grab a calculator. Remember, we're not looking for any angles, so we are not hitting the second button. Just flat out in your calculator right now, hit tan 44 equals, and I get 0.9656. I'm going to go out 4 digits, equals 16 over x. Let's solve this. Okay, in this case, I've got x times that junk, which gives me 0.9656x. On the other side, I have 1 times 16, and that's 16. So for this one, I still don't have x by itself, so I gotta do one more step. How do I get x all by itself? I gotta divide that stuff. So divide by 0.6, blah, blah, blah. So I've got to do 16 divided by 0.9. There's a 6 in there. 0.9656. I've got 16.5700 something. Okay, so I want this to the hundredths place. So where is the hundredths place? This is my decimal. That's the tenths place. This is the hundredths place. So that's the last number I'm allowed. I have to look at this 0 to see if I have to shove 7 or not. 0, I do not shove 7. So my answer is 16.57. Number 5. Find the measure of angle R. So in my picture, I'm looking for this angle right here. Once again, I have a right triangle, so I know I'm going to be dealing with trig or Pythagorean theorem. Pythagorean theorem is if I have 2 sides and I want the third side. So I don't want a side, I want an angle. I'm looking for an angle. Got it? Remember that, because remember, we're going to have to hit the second button in our calculator for this guy. Okay, so I circle the angle that I want. So across from that angle is going to be my op. Across from the right angle is going to be my height. My missing, this side over here, is going to be my adjacent. Okay, so it looks like I've got my R, my theta is my missing, right? Well, you can call him theta, or you can call him R, whatever you want. That guy's missing. That's the guy we want. But I have my op is 822, and I have my adjacent is 72. So it looks like I'm dealing with O and A, so I'm going to be using tangent is opposite over adjacent. So remember, same thing, write your word, tan, then your angle. I don't have it. I'll call him theta, or you can call him R, doesn't matter. Then I put my equals, and then I put my fraction, opposite over adjacent. Opposite 822 over adjacent 72. Now remember, I'm looking for an angle now, so I'm going to have to hit my second. So hit your second button, and then hit tan. And this reminds you, this is going to pop up like this on your calculator, and this is inverse tangent. Remember, it looks like tangent -1, and then it's going to have a parentheses, and you put in your parentheses 822 over 72. So, and I'm going to use divided by, so I'm going to use the divide. So 822 divided by 72 equals, I get approximately 84.9941. Okay, let's go up here. It doesn't tell me what to round it to, so I'm going to be a normal human and just round this to approximately 85 degrees, because 84.99, that's pretty close. Okay, look at number 6. Sorry, I kind of went into little 6's space. Okay, number 6 says, what is sine of t? Now remember, are they looking for an angle? what are they looking for? Are they looking for an angle? Are they looking for a side? They want sine of something. So they are looking for neither of these, which means do not pick up your calculator. No calc for this baby. You just write the fraction. So, oopsie. A no calc. So we just want just fraction. Just a fraction. Okay, so we need sine. So looking at your little key, sine is so sine of t equals, let's circle t, let's label all our sides. So that means this is my op. This is my, across from the right angle is always my hype. And then the last guy is my adjacent, which I don't even care about because sine is just opposite over hypotenuse. So my opposite is 33. And my hypotenuse is 65. Right here is the answer to my question. 33 over 65. Leave it alone. No calculators, just a fraction. You see the difference. It does not ask for the measure. This one asks for a measure of angle R, so it's asking for the angle. This one just says sine. Don't be tricked by that. Stop being extra. Okay, number 7. A kite has a string that is 60 meters. On a windy day, all the string is let out and makes an angle between 20 degrees and 36 degrees with the ground. Find the minimum and maximum heights of the kite. Okay, so we have the ground. So let's draw the ground. We have a kite. Here's my little kite up in the sky. It has a string that's blowing somehow. The string has a length of 60, so this is 60. And we want to talk about the height of the kite. So remember, height is going straight up and down. So this is going to be my height. G-H-T. So that's the height of my kite. So I do have a right angle here. Okay, so it says on a windy day, the string lets out, makes an angle of 20 degrees to 36 degrees with the ground. So down here, it could be 20 degrees to 36 degrees. So we want to know the minimum and the maximum. So we want to know it at 20 and at 36. So we kind of need two triangles that look the same. So let's make this one be the 20. Let's draw another one exactly like it, except make this one be 36. And we are still going to be looking for the height of both. Okay, so I got to find both of these. And it's asking me for two answers. Okay, so let's find, let's do this green triangle first. So circle this. This is going to be my opposite. Across from the right angle is going to be my hype. And I don't even care about the bottom because we're not even asking. We're just talking about these two. So clearly I'm dealing with H and O, right? Which is going to be sine. So that means I need sine. Write your angle next. 20 equals your fraction, which is, SOHCAHTOA is S-O-H. So I need opposite on top. So that's my missing piece. I got my opposite over my hypotenuse, which is 60. I'm just going to call this guy X. I don't like to have an O because it looks weird. Sometimes think it's a 0. So hit sine of 20 in your calculator. And I get 0.3420 equals X over 60. Put this over 1. Crisscross multiply. I mean, X is equal to, I've got approximately 20.5, around 20.5. Now I got to do it with this same orange triangle, same thing. Across from this angle is my op. This is still my hype. I'm still going to be using sine. So I've got sine, but this time it's sine of 36 is equal to my op, which we called x over my height, which is 60. So I need sine of 36 is 0.5877 is equal to x over 60. Put that over 1, cross multiply. So I've got approximately 35.3. So these are my two numbers I have, this one and this one. It says find the minimum and the maximum of the, okay, so that's the minimum, 20.5, and the maximum is 35.3. And that is meters for both of these. Number 8, calculate the area and perimeter. Calculate the area and perimeter. Okay, so let's do area first. Okay, what is this shape? It looks like I have a rectangle on the bottom. So the area of any kind of parallelogram is base times height. And then I have on the top this triangle. And the area of a triangle is going to be 1/2 base times height. You might want to color code like I am. Okay, let's do the rectangle first. So the base is 50 and the height is 10. So the area of this piece is 50 times 10, which is 500. And then for the pink piece, I need 1/2 the base times the height. So it looks like I have the base. So the base here is 30, but I don't have the height over here. But this is clearly a right triangle, so I can use some trig, or I can use Pythagorean theorem. And actually, for this problem, you could do either one you want. I'm going to go ahead with Pythagorean theorem because I have this side and this side. So I'm going to do a squared plus b squared equals c squared. So remember, I can call this guy a and this guy b, as long as my hypotenuse, this is my hypotenuse opposite my right angle, is my hype. And so my c squared has to be 40. So this is my c. So I've got 30 squared plus my b squared, which I don't know, is equal to 40 squared. Okay, so 30 squared is what? 900 plus b squared equals 40 squared is 1600 minus 90 from both sides. I've got b squared equals 700. I got to take square root of both sides. What's the square root of 700? Put that in your calculator. So I get b is equal to about 26.46. Okay, I'm going to go back to my picture, 26.46. So this side right here is 26.46. So that's my height, 26.46, 26.46. So I've got to do 1/2 times 30 times 26.46. In my calculator, remember 1/2, do 1 ABC2 for your 1/2. Type all that in. And you got 396.9. So this part is 396.9. So I got to add these two together. So if I add that one plus 500, I'm going to get the area of the whole thing. So add those together. And what do you get? 896.9. And this is meters squared. So this is my area of my shape, area. And then I need perimeter. And perimeter is when you add up all the sides going around the outside. So perimeter. That means I have to take this side plus this side plus that side plus that side plus that side plus that side. Okay, so how are we going to get around here? First of all, how long is this piece right here? You see it's 30 from here to here, and there's 50 going all the way across. So all the way across is 50, and this much is 30, so the rest of it must be 20. Okay, so to go around this figure, I'm going to start right here. So I've got a 20 down here, plus a 10. I recommend you drive all the way around the figure so you don't miss any sides. Plus 50. Plus, how long is that piece right there? If it's 10 over here, it's 10 over here, right? Plus 10. Plus, we just found that piece up there, 26.46. And then down this angle is 40. Okay, we got to add all those together. Oopsie. Can't see my screen. Okay, you better check my math. I got 156.46. And that would be meters. Double check that though. Number 9. In a right triangle, XYZ, angle X is the complement of angle Z. What is equivalent to sine Z? Okay, so you have no picture, so this is a little bit confusing. But you do have a right triangle, so start by drawing a right triangle, any kind of right triangle. Now, you're not sure where these letters go, but it says angle X is the complement of Z. So what's a complement? That means adds up to 90 degrees. So that means the X and the Z. So X plus Z equals 90, they're saying, when they say they're a complement. So that means that X cannot be this angle and Z cannot be that angle because this angle is 90 all by itself. So that means X and Z must be the other angles. And that means in XYZ, that means this guy must be the Y. So stop and think what it says before you just willy-nilly label your stuff. Okay, it says what is equivalent to sine Z? Now remember, when you don't have any numbers, that's your clue to do that little trick. Remember, go on your hypotenuse. This is my hypotenuse. And write sine equals cosine and cosine equals sine. Because then it's going to help you remember how to set this up. So that means sine of X equals cosine of Z. Oopsie, cosine of Z. And if you use the bottom things, cosine of X equals sine of Z. Remember, it's just sine and cosine. No tans going on for this. Okay, so what did they say? Sine of Z. So do we have sine of Z? Yep, we have it right here. What's sine of Z equal to? It's equal to this guy right here. So our answer would be cosine. Ooh, I guess I should do it in a pen, huh? Cosine. Ooh, cosine of X. This guy right here. Okay, let's take a look at this one. Cosine of O. So cosine of O cosine of O equals 0.85. What is sine of N? Okay, so we have the same thing going on. Cosine of O. So if I look at my hypotenuse and write those words, this is easy peasy lemon squeezy. Let's write those words on here. So this is sine equals cosine, or cosine equals sine. So that means sine of N equals cosine of O. And also, on the bottom, cosine, gosh, why is my pen so weird, of n is equal to sine of O. So, if I say cosine of O, cosine of O is right up here. That's equal to sine of n. Look, it's the exact same thing. So your answer is going to be the exact same number. So if cosine of O equals that, then sine of n is equal to the exact same thing, because these two are equal to each other. Look, they're exactly equal to each other. So, and look how they trick you. Round the answer to the nearest hundredth. Duh, it's already rounded to the hundredth. So they just think you're about to have to do math, and you don't. You just had to notice they were the exact same. Okay, Ed and Joe are at City Hall. Ed plans to stop at the cemetery and then go to the gas station. Joe needs to stop at the greenhouse before heading to the gas station. Who will be traveling the shorter distance? So, where are they both? They're both at City Hall. They're both here. Ed is going where? Ed is going to the cemetery and then to the gas station. So Ed is green. Joe is going to the greenhouse, which is kind of cut off on the picture, up to the gas station. So Joe is orange. So we need to find these distances. Now remember, you cannot count diagonal blocks on a graph. You can count straight across blocks. So down here, you see how this is going straight across? We can count bubbles there. So let's go ahead and do that. Okay, so let's be Joe first. So Joe is 1, 2, 3, 4, 5, 6. So that's 6 across. This right here is diagonal. So remember what we need to do. We need to make an fake right triangle. So let's make a fake right triangle. So this is going straight up and over and diagonal. So there's my right triangle. It's very skinny. If I count bubbles straight up on my right triangle, I get 11. And then across the top is 1. So I'm going to do Pythagorean theorem. So a squared plus b squared. Why does that keep doing that? It's driving me crazy. A squared plus b squared. You see how the eraser is showing up there. Equals c squared. So that's 11 squared plus 1 squared equals c squared. So that's 121 plus 1 equals c squared. So that's 122 equals c squared. 122, so we need to take the square root of both sides. The square root of that is about, what do we got here? 11.0, I think 45. Okay, so that is, so Joe has to go a total of 6 plus that. So that's about 17.045-ish. That's how far Joe is going. Ed is green, so he does not have any little right triangles. I mean, we gotta make some right triangles, so I'm gonna go across and like that. So counting the little things up, this is a 6 and a 3. So I gotta do Pythagorean theorem. 6 squared plus 3 squared equals c squared. So 36 plus 9 equals c squared. That's a 45 equals c squared. Square root, what's the square root of 45? It's about 6.7. Okay, and then he still needs to walk this distance right here. So you need to make another right triangle. So I'm going to make this one go up and over. And that one's like 5 and 8. So you got to do the Pythagorean theorem with 5 and 8. So 5 squared plus 8 squared equals c squared. So that's 25 plus 64 equals c squared. So that's 122. Nope, that is, I was looking at my other thing, the other one I just did. 89 equals c squared. Take the square root. Square root of 89 is about 9.43. Now I'm going to have to add this one and this one together. So add these, because this is his whole route. And that's going to give you about 16 point something. So who is traveling the shorter distance? This is Joe and this is Ed. So obviously Joe is going farther. So Ed is the shorter distance, and then it says how much shorter, so you would have to subtract, but I'm kind of out of room, so you can go ahead and subtract those and figure out the rest of your answer. And the last one you're going to do here, it says what's the perimeter of quadrilateral that with these vertices? Now what you're going to have to do is put all of these vertices on your graph. So your first step is going to be to graph it, right? And then, if it's horizontal or vertical, then you can count bubbles, right? To get how far it is. They're asking for perimeter, so you're going to have to go all the way around the outside, just like we did for perimeter for this. Remember, we went 1, this, blah, 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 and we added up all the pieces all the way around it. So you're going to have to go all the way around the quadrilateral. So if it's vertical or horizontal, you can count bubbles. If it's diagonal, then you're going to have to make your little fake right triangles and do Pythagorean theorem. Okay, so go ahead and do that one.